Hi everybody, welcome to our 11.6 notes on graphs of quadratic functions. You guys probably already know what a quadratic function is. It's a function that has an x squared in it. But we're going to talk about how to graph them. And really what we're going to do throughout this section of notes is we're going to look at the basic graph of just f of x equals x squared. And then what happens when we do different things to that graph? How does it affect it? Okay, so we're going to start out by just graphing f of x equals x squared. And if you're not sure how to graph something, a table of values is a wonderful way to start. So that's where we're going to start. We're just going to start with a nice little xy table. So when x is -2, what's y? I'm going to substitute -2 in for my x squared, and -2 squared, so that would be -2 times -2 would be +4. For -1, -1 squared would be -1 times -1, which is +1. If x is 0, 0 squared is 0. When x is +1, 1 squared is 1. 2 squared is 4. And just for fun, let's throw in the 3's as well. So -3 squared would be -3 times -3, which is 9. +3 squared is also 9. And then we have a lot of points that we can plot and see what it looks like. So my first point would be -2, 4. My next point is -1, 1. Then I've got 0, 0, 1, 1, and 2, 4. And then we threw the 3's in just for fun. So I've got -3, 9. And +3, 9. And so with our dots, we are going to connect them to form a smooth curve. What you find is that they form a U shape, which is called a parabola. I am going to put arrows because they do keep going forever in both directions. But that's generally what it looks like. It's not a V, don't make it pointy. It is going to be a U shape, and in my math lab, they do have a parabola tool. For the parabola tool, what they expect you guys to plot, they want the vertex, which is this like bottom part of your U, or if it's upside down, it'll be the top part of the U. They want the vertex plotted and at least 1 point on either side. So 1 point on the left side and 1 point on the right side. That's what my math lab is going to be looking for, just to let you know, okay? But that's the basic graph for f of x equals x squared. Next up, I want to see what happens when I do things to that graph, okay? So I'm specifically going to look at what happens when I multiply x squared by something. What if I have a leading coefficient? So I'm going to have 2x squared, 1/2 x squared, and -x squared. And I want to see how are those look different compared to the regular x squared graph. So again, I'm going to have the same points. I'm going to have -3, -2, -1, 0, 1, 2, and 3 for my x values. And I'm going to make a nice table for all three functions. Okay. So for f of x, I'm going to do 2x squared. So we are going to follow order of operations and do our x squared first, and then multiply by 2. So if for f of -3, for example, you would do 2 times -3 squared. And we're going to do -3 squared first, which is 9. And then we'll do 9 times 2, which is 18. For f of -2, we're going to do -2 squared first, which would be 4. And then 4 times 2 would be 8. For -1, -1 squared is 1. And 1 times 2 is +2. When x is 0, 0 squared is 0 times 2 would still be 0. 1 squared is 1 times 2 is 2. 2 squared is 4, and 4 times 2 is 8. And 3 squared is 9, and 9 times 2 is 18. Okay, so there's our f of x points. And we can go ahead and plot those and see what they look like. Okay. So -3, 18 is not going to fit on my graph. It's going to be too high up. But let's start with negative 2, 8. Negative 1, 2. 0, 0. Positive 1, 2. 2, 8. And yet again, 3, 18 is going to be too tall for my graph. And I'll connect the dots to make a nice smooth curve. So one thing with parabolas that you'll notice is they always have symmetry. So symmetry, it's like a mirror image. I could make a little dotted line right here and reflect it over. So what's really nice is once you found where that vertex is and the points on the left side or the points on the right side, you can flip them over to the other side, which is pretty neat. Okay? But comparing this to our regular x squared graph, so this is f of x, which is 2x squared. I noticed that this one, it's a little bit skinnier and it's almost like I stretched it out. All of my y values are 2 times bigger than they used to be, which if you think about if you made a little u on a thing of silly putty and then stretched it, that's what we just did to our graph, is we stretched it by 2. Okay? Let's see what happens if we do 1/2 x squared. So for negative 3, we're going to do negative 3 squared, which would be 9. And half of 9 is 4.5 or 4.5. Negative 2 squared is 4, and half of 4 is 2. Negative 1 squared would be 1, and half of 1 is half, or 0.5. 0 squared is 0, and half of 0 is still 0. And then I have that symmetry, so I know for negative 1 it was a half, for positive 1 it'll also be a half. When x was negative 2, y was positive 2. When x is positive 2, it'll also be positive 2. And for negative 3 went to 4.5, positive 3 is also going to go to 4.5. So if that kind of cuts your work down in half, you're certainly welcome to do that once you figure out where that vertex is. Okay? So let's plot that. So I've got the points negative 3, 4.5, which is right here. My math lab doesn't really allow you guys to do decimal plotting unless it goes by halves. But it's nice to know where things are. So then next up we have negative 2, 2. We have negative 1 and 0.5. We have 0, 0. We have positive 1.5. We have 2, 2. And we have 3, 4.5. Okay. So making a nice smooth curve here, what you'll notice is that this one is wider. Okay. All of our y values were half of what they used to be in example 1. So if you took example 1, and again, think about your silly putty. Imagine you drew a U on some silly putty. Instead of stretching it this time, imagine you're shrinking it, you're pulling it together. Okay? That's what this does. Okay? And it makes it a wider graph. Last one is, what if we throw a negative on top? So what if we do negative times x squared? And remember what this is. So like for negative 3, this would be the opposite of negative 3 squared. So you do negative 3 squared first, which would be 9, and then the opposite of 9 is negative 9. With negative 2 squared, that would be 4, and the opposite of 4 is negative 4. When x is negative 1, negative 1 squared is 1. The opposite of 1 is negative 1. For 0, 0 squared is 0, and the opposite of 0 is still 0. When x is 1, 1 squared is 1, and the opposite of 1 would be negative 1. For 2, 2 squared is 4, the opposite of 4 is negative 4. 3 squared is 9, and the opposite of 9 would be negative 9. Okay? And again, we're seeing that symmetry. For both 3's, we had the same y value. For both of the 2's, we had the same y value, and so on. Okay? So let's go ahead and plot this. So my first point would be negative 3, 9. Or negative 3, negative 9, excuse me. Our next point is negative 2, negative 4. Then we have -1, -1, 0, 0, 1, -1, 2, -4, and 3, -9. And I'm just connecting the dots here to make a nice smooth curve. And what happened with this one? It flipped upside down, okay? So when you have a negative coefficient, that's what happens, is your parabola is going to flip upside down. It's going to be an upside down U instead of a right side up U, okay? So let me label everything and we'll summarize really quick. Okay, and you probably want to label your graphs so that when you go back, you know what you're looking at, okay? So just to summarize really quick, that 2x squared, the f of x graph is skinnier compared to our x squared graph. The 1/2 x squared graph is wider than our original x squared graph. And the negative x squared graph is flipped. Okay, so it's an upside down U instead. And you can't see that. Here you go. Alright, so hopefully that helps with the change in leading coefficients, okay? The next thing that we're going to look at is what if we have an x squared graph and we add or subtract something at the end, okay? What does that do to our graph? So I've got two of them for you. F of x is x squared plus 3. G of x is x squared minus 2, and let's see what happens, okay? So I'm using the same x values again, and let's see what happens there. So like f of -3, if I substitute that in, that would be -3 squared plus 3, and we'll see what happens. -3 squared would be 9, and 9 plus 3 would be 12. For -2, -2 squared is 4, and 4 plus 3 is 7. If x is -1, -1 squared is 1, 1 plus 3 is 4. If x is 0, 0 squared is 0, plus 3 would be 3. If x is 1, 1 squared is 1, plus 3 is 4. For x is 2, 2 squared is 4, and 4 plus 3 is 7. And last one, if x is 3, then x squared would be 9, and 9 plus 3 is 12. And let's go ahead and plot that. Okay. So my first point is -3, 12, and again, my graph only goes up to 10, so it's a bit off my graph. It would be up here somewhere. So let's start with -2, 7. Then I have the point -1, 4, the point 0, 3, the point +1, 4, and 2, 7. And yet again, 3, 12 is going to be too high for our graph. But I can go ahead and plot it from here and make a nice smooth curve. So what I'll notice with this one compared to the regular x squared graph is it's the same shape. It just got moved up 3. And that's all it did, is it just took our y values and made them 3 bigger than they used to be, which just moves it up 3. Okay? So what do you all think is going to happen with the next one, with x squared minus 2? What do you think that minus 2 is going to do to our graph? So if plus 3 moved it up 3, minus 2 might move it down 2, huh? So let's give that a try. So g of -3, just to show you what we're doing here, I would substitute that in and do -3 squared minus 2. So -3 squared is 9, and 9 minus 2 is 7. And let's try -2. -2 squared is 4, and 4 minus 2 is 2. -1 squared is 1, and 1 minus 2 is -1. 0 squared is 0, and 0 minus 2 would be -2. 1 squared is 1, and 1 minus 2 would be -1. 2 squared is 4, and 4 minus 2 is 2. 3 squared is 9, and 9 minus 2 is 7. Okay. Plotting really fast, we would have -3, 7, -2, 2, -1, -1,